All right, we are ready. So, exit. Save. Sir. Uh, Back to software for just a little bit. I swear, just a little bit. There's something I'd love to talk about today. That's sort of a fun project that recently got working. It's going to combine a couple of different interesting things, including a particular cloud provider I enjoy using, DigitalOcean. A fantastic way to use them or to really learn and grok about any other cloud provider or modern infrastructure, Terraform. And a great way to procedurally configure arbitrary virtual machines called CloudInit. That's fairly standard across providers. So we're going to put this into context a little bit by saying we'd like to deploy our own Minecraft server. I have a couple of kids who love Minecraft. I want to spin it up for them, but in the past, I've just done that on my tower at home. And what I'd really like to do is put it up on the cloud behind a specific domain so they don't have to share IP addresses with their friends. And I'd like it to be persistent on that domain. And I don't want to worry about, setting up port forwarding through my home firewall and everything like that. So there's a couple of really interesting advantages that this approach gives us, and hopefully you'll see what they are. So first, let's think about what is the fundamental element that we want to deploy. We could go, theoretically full up Kubernetes or try and deploy a container on top of some sort of virtualized host. But the atomic unit for most cloud providers is instead, especially when you're talking about the, things that aren't quite as distributed or orchestration driven, like a single node microserver, is a virtual machine of some kind. So in the case of DigitalOcean, those virtual machines are called droplets. So let's start by creating a droplet here within Terraform. We're going to use the Terraform provider here. This is actually one of my favorite things about DigitalOcean is the fact that their Terraform provider is just top-notch, like it's Azure levels of quality, better than AWS. Lots of fun things that you can mess around with here. Let's take a look at the DigitalOcean droplet specs. So it's pretty easy to spin one up. One caveat is there's a couple of special terms here, like which image you're using, what the region is. You'll want to look up the slug site to see exactly what's available right now. Let's put this together. It's not enough to deploy on its own. There's a few other things we'll need to define. In this case, we're going to use 2204x64. So that's the Ubuntu version, of course, the processor architecture. We're going to just call it our DigitalOcean droplet. We need to say what region it's going to be deployed to. We'd like that to be a variable, so we're going to say there's going to be a variable, Terraform variable called do region. That's going to let us define and customize where people who use this Terraform might deploy it to. And the size of the droplet itself, we're going to say, is one of these basic models. This is 4 virtual CPUs and 8 gigabytes of RAM, assuming I don't say a BG. Let's look at the slugs for a second. There's also a volume that's going to go into this, just sort of a sneak peek, but that, if you're worried about expense, in addition to sort of the $200 credits that they'll give you when you initially sign up, this one goes about 7 cents an hour. So this is not going to break the bank. For each month that this runs, right, it's going to be, let's see, 7,143, 24 hours a day, 30 days, so $50 a month. And that's about what I'm paying for my full up virtual private server on a different provider. So it's pretty reasonable price. Then we're going to want to deploy this with some SSH keys that we will look at how to provide or define later on. These aren't necessarily needed for production, but they are going to let us log in, just sort of debug and poke around, make sure everything's going the way we want it to. So this is where CloudInit comes in, and we're going to use some fun Terraform tricks here. So CloudInit basically is a way to use a YAML file to construct blocks of specifications for your VMs that will be run when that VM is spun up on the cloud provider. So it's not unlike Ansible insofar as you're sort of providing a playbook or a set of instructions, a specific configuration that should be applied. These packages should be installed, these files should be written, these variables should be applied with it, etc. And that CloudInit configuration can be part of a set of files, including the provider configurations that are installed on that VM to run when it is spun up. So in this case, in addition to defining some SSH keys, we're going to say there's some user data, which is our CloudInit content. We're going to populate that user data from a YAML file that's going to be templated so that Terraform can interpolate it as part of the deployment. And the result of that template, that rendered template, is going to be the content that we pass into the VM as a CloudInit data. This is a nice way to procedurally define it, and where you can pass through variables to be evaluated on the machine that is doing the deployment, right? Your local system. So what's next? Well, this is going to be part of, in DigitalOcean, it's called a project. This is sort of like a namespace. You'll notice this is a personal preference of mine. I put different resources in different files, just makes them a lot easier to find and understand the overall structure of the project. So we're going to call this the DigitalOcean Minecraft something something server. I had a backronym made up for it at one point for encapsulation of cloud resources. So this is just a nice way to group resources that are focused on a specific application. It's a logical namespace, effectively. Among other things, this means that you can, after tying certain resources to the project, you can delete the project and it will clean up all of the resources, right, for cost control purposes, etc. We're going to set this for demonstration purposes, and we're just doing this in the development environment. We need to define what resources are part of this project. So our droplet have a universal resource number. We're also going to have a domain. We're going to register and bind. And we're going to have, as I mentioned, a volume that we're going to mount in here for persistence. So this defines our project. Couple other things that go into this. Oh, excuse me. And there we go. Okay, so before we actually deploy this, we need to pass sensitive values to Terraform to be able to, for example, identify what our API key is. So if you signed up for DigitalOcean, you'll know that there's this dashboard here. Let's pull it out for a second. Here's a sneak peek, by the way, at the Terraform graph for what we'll be deploying. Of course, now it wants verification code. Just a second. There we go. All right. The streaming bandwidth is really making this go slow. Okay. Should be able to drag this over now. This really is something that I should show. So down here under API, you will want a token. So you'll see some tokens there. You'll want to create a new one if you haven't already. And we are going to find sort of the inputs in a variables file here. But we're not going to store the values here because we don't want them accidentally getting committed or touching disk any more than they have to. So there will be a DigitalOcean token for the API. We'll help this self-document with a little description. Some other variables we're going to want to define here are things like domain names. We can pass in and specify how this is going to be registered, what sort of A records it will have. Of course, this can't be just anything. This should be a domain that you have registered and is pointing to DigitalOcean name servers. we'll want to define, in this case, these are Minecraft variables. When you set up a Minecraft server, there are operators of that server, specific users that are flagged. As a way to say this person can add people to the whitelist, for example. So before you actually have the whitelist populated, you'll need an operator in there actually within the universe typing, /whitelist commands and things like that. So this is also going to be defined. This is the name of initial operator user. That can't just be any old name. It has to be specifically a Minecraft account. And then lastly, this is something we saw already. We want to define what region this is going to be deployed to. Come on, formatter. You can do it. There we go. Okay. Let's add a quick get ignore here because we want to TFRs, make sure that's protected. So we've defined what those variables are, sort of the interface for the infrastructure deployment. We haven't actually defined what their values are. So if we define a TFRs file here, Terraform will find them automatically. But there's a couple ways these values could be passed in. So let's say, for example, we want region to be SFO3. Terraform will find the DO region value and use it when it's interpolating the infrastructure. Other ways that you could also define this would be through environmental variables. So there's a neat trick with Terraform where if you have an environmental variable that says tf_var_, then name of variable like DO region. So if you're in Linux, you'd look at it like that, or if you're in Windows, you'd look at it like that, right? Terraform will detect tf_var_ and say, hey, this variable looks like it matches the name of a variable in the infrastructure. I'm going to use that when I interpolate the infrastructure for deployment purposes. That's awesome stuff. So let's focus a little bit. Let's just say we want to get the droplet up and running first, right? So we can log in and debug and all that stuff. So we need a key to be able to do that procedurally, right? We don't want to set up a specific, root user and password combination or something else that's going to leak. So we're going to use a very cool thing in Terraform, which is the built-in TLS provider. This is a fantastic way to generate TLS resources on the fly, like self-signed certs, M values, or in this case, a key that can be used to construct an SSH. Yeah, I can type, I swear. So with this resource defined, this is not a DigitalOcean thing. This is a built-in, a provider that's built into Terraform. We can then go ahead and define what is our DigitalOcean resource, which is the SSH key that will pass to the droplet. So in this case, it has a name. And we say, here's the public key, because that's the only thing the VM needs to know, right? The VM isn't the user. It needs to accept the login from the user. In this case, specifically, it needs the public key open SSH value. Did I spell that right? TLS private key. Yeah, I got that. Okay. TLS key. Doesn't always match up with the highlighting, but when it does, it's nice. So now if we go back to our droplet, what we see is this SSH keys list. It will recognize that DigitalOcean, since this is a DigitalOcean droplet, right? If you have to say, hey, there's this key, you should accept it when people use that key to log in. So another thing we're going to do here, just to make sure that we can use that, is define some outputs. So variables are sort of the inputs to configuration of the infrastructure. Outputs are things that you want to know after the infrastructure is applied. So in this case, we want to know what the actual private key is, because that's what we're going to use as the user to log in, right? So what we can do is, once this is deployed, first we want to mark it as sensitive. This is a private key. Once it's deployed, we can do Terraform output -raw, private SSH key, and pipe that to an actual ID underscore RSA file, and use that file as the identity with our SSH commands. We want to log in and debug and poke around. That isn't strictly speaking necessary for the long-term maintenance of the infrastructure. This is mainly just something that will help us debug and verify what's going on. The other thing we're going to want to know is what the actual IP address is of this system, so we know where we're logging into, right, before the domain is registered. In this case, we're going to get the IP4 address. Is that right? Yep, that looks right. DigitalOcean droplet. Okay, so these are our outputs. This one's not secure, so when Terraform does the application of the infrastructure and deploys it, it'll actually just say there in the console, like, here's the address of the stuff that you wanted. Okay, so this is enough to get started, but there's two specific things that are missing, one of which you probably already noticed. So let's do that one first. I mentioned the CloudInit configuration. That's just a YAML file, but in particular, we're going to want, so cloud config, update our packages, upgrade the packages, right? So it's not just the status. It's tracking. Okay. There's a few other things we're going to add here too, but first I want to show you something. So this is the YAML file, and then we'll add the extension TPL here to indicate that this is a template. This is going to let us reference specific values like that admin UUID, right, for example. Specifically to tie that in, though, we need to define a set of data references for Terraform to recognize and interpolate. So the template file, user data YAML is what we'll call it. We pointed at the template we created relative to module path. And then we say these are the variables you're going to pass in. So it's going to need to know a few things to write to that CloudInit file. In this case, we'll just reuse the same names, so it's pretty obvious what they are, where they're coming from. The exception here is we're going to mount a volume to make sure the state is persistent, even if the VM has to restart, right? So we'll mount this to a specific path. That's going to have the name of the volume, and then we'll say there's a folder in there called Minecraft that's going to be used. So now we can reference the contents as we did when we defined this droplet, right? So this is the user data. It's going to come from the rendered template, but now we actually need to finish filling it out. So there's a couple of things that we're going to need to specify here. First is the list of packages to install, and there's a lot more to CloudInit files than this, but this is enough for these purposes. We're going to need OpenJDK. Optionally, we can use Screen to launch the process, but that's not strictly speaking necessary. There are many different kinds of blocks that can go to CloudInit, and keep in mind this is one of several that will be running on the VM, including some defined for the provider. We're also going to want to make sure there's a certain set of files written, so there'll be more than one here. So in persistent volume, remember that's a variable we're passing in. We're going to say there's a script, and that's how we're going to start. It's going to have specific permissions, and it's going to have specific content. So pipe, this is just a bash script, change basically, right, because this is just your standard Minecraft launcher. Persistent, I didn't spell it. Persist volume path. And then you're going to run the fat jar, as they call it. In this case, we're going to say it has this set of resources, and we're going to run the jar. That will be, let's see, without a GUI there. Okay, so there's a few other files that are going to go in here, and if you're wondering how we get there, you are not alone. We're going to need to find some server properties for the Minecraft server. Persistent, let's see, permission. Yep. That's going to have specific content. In this case, this is where you would customize, you know, different things, what biome you might have, for example. We're going to say Difficulty is normal, and we want a whitelist because we want to control who's going to log in here. Another resource we want written is our list of operators. So this is where the other variables will come into play. Specifically, that's going to be a JSON file that looks a little bit like this. Pass in the string value of that user's UUID. It's going to have a name, and we need to find a level, basically permissions level for the operator. Okay, that's enough. Next block is going to define exactly what command is run when the VM starts up. So we're going to say if it doesn't exist, make it and go there. Since it is persistent, this will only be created or changed on the first boot. Then we're going to actually get the server, the fat jar for the server. You can check or verify this link from the Mojang website. We're going to use, in this case, Java version. And I am just going to cheat a little bit and copy this hash over. Data Mojang, yep, okay. And we're going to say we accept the ULA, which is done by writing a specific key value pair indicating so to txt or in the Minecraft directory. And then we're going to call the script that we define. And of course, that script defines how Minecraft will be started. Lastly, just for sort of verification purposes, another trick that's useful sometimes, since you don't always see things on startup logs, is defining like a unique environmental variable in your CloudInit, so you can verify even if you miss, like in the log messages, you don't know where to find them or don't know how to grep. You can see like echo myvar right when you initially boot in, you make sure, okay, it got to that point, evaluated and applied that configuration. Okay, so what else are we missing here? If you used Terraform before, there's actually something pretty important missing here, which is the definition of our providers. We have a couple of different providers we're using, but only one of them is not built in. That is, of course, the DigitalOcean provider, and this is how we pass in that API key that it's going to use to have the authority to deploy all of our stuff using our account. That's not right. All right. Okay. So we have outputs. There's one other thing that's missing here, which is our persistent volume. So we're going to attach a volume under that path that you saw in the CloudInit file. So we need to find that volume as a resource. That volume has a region where it is, where it exists within the data center. This thing didn't say it's only 100. I want to say that's gigabytes in units. Needs a file system. Let's say Explorer, always a good default option. Persistent storage for Minecraft state. And of course, it always helps when you can actually spell things correctly. Okay, but that just means the volume exists and the VM exists, right? We need to define a way that one is mounted into the other, basically a mapping between the two. So let's add a mount resource, or in the DigitalOcean parlance here, it's a volume attachment. So this is just a cross-reference. So we'll say this droplet has this volume. And that's it. Well, where is it mounted to? This is where, if you remember, that volume has a specific name, right? So if we look at our droplet configuration, or actually, see, defined here, there we are. That volume will be mounted. Remember, it has a name under mount name of volume on that machine. So let's see. We got our SSH key. We have our project. We have our mount. We got our droplet. We have our domain. No, we don't. Okay, so we need to define our domain. Again, this is something you should have already registered. I have like domain names just lying around from different side projects, so this is pretty straightforward for me. And then all of that A record registration and so forth, so long as it's being defined by the DigitalOcean name servers with your registrar, it will be taken care of if you just say, ocean droplet. For that A record, you register it with the address. For that name, register it with the address of my droplet, and that's it. So we have a fun trick that we can do here, which is, if I can do this correctly, requires some Linux tools if you're on Windows. In this case, I'm launching WSL, so I can make sure to run it. There's some nifty things built into Terraform, including the ability to, once you've defined your infrastructure, back out the state or the graph of that infrastructure. So in this case, we can run this command here. Terraform graph will generate the definition, and then we can pass that to graph.viz. You can barely see that command, huh? Saying generate an SVG or vector graphic using that file, that output. And what you'll get is something like there we go. So technically it doesn't show the full dependencies because there's more in the droplet than just the domain, but that gives you an idea. Like, here's the droplet. It's going to have a mount defined for it. It's going to be using this template. It's going to have a volume, etc. So there's a few things actually I'm not sure about here, like why the volume is related to the CloudInit configuration. Like, this should be here and that should be there. Maybe those two should be swapped. But this is a nice way to just sort of visualize the state of what you're deploying. Though, and again, on Windows, you'll probably want to do that in WSL. So at this point, you would go in and, there we go. Actually, you know what, let's use terminal for this. Monk. You do something like, I don't want PowerShell. No one wants PowerShell. Whoever wants PowerShell, my God. Okay, Terraform init, then Terraform plan. Once it grabs all the dependencies, and Terraform apply, right? And when you do that, what you'll see is this project show up, and you should see, there we go, there's our droplet, there's the domain. Let's look at the specification for that droplet. You see Minecraft is running, volumes. Did we mount our volume? Yes, we did, there it is. You can also, if you don't want to SSH in, you can look at the console here directly within the DigitalOcean management panel. Hey, look at that. So, remember our volume? There it is. Mount everything under Minecraft. Let's look at, make sure that ELO is written. Hey, there it is. Yep, so we know CloudInit went through and applied the configuration. There's the Java process that's running Minecraft. We are good to go. At this point, I suppose we could, you know, we came this far. Why not? Let's take a look. There is a whitelist for this. I don't mind sharing it because, you know, you're not on the whitelist if you're watching this video. But let's just make sure it's working. Hint, it's working. Sneak peek. Come on. You can do it. Hey, you can do it. Hey, yes, you can. You can do it. You can do it. Hey, yes, you can. Lots of other things you could browse. We don't have a database here, of course. We're not using container registry. We could back it up if we wanted to, but having a persistent volume is probably good enough. Other good things to add to while we're waiting, your git ignore or Terraform artifacts, of course. Maybe your log file. Okay, this might be taking too long. Nope, there it is. As soon as I said it, right, it was going to pop up. Now, of course, we need to make sure it's actually going to come on the stream. It's not going to do weird display adaptation things here. Let's see. Let me check on Twitch. Hey, look at that. It's probably really loud, though, huh? Okay, no, I muted desktop audio. Thank goodness. There we are. So under multiplayer, you can add servers. So you would add it under your domain and share with your friends, and of course add them to the whitelist. Since that's whitelist is written as part of the state, it should persist. And here is our world. You can tell that this came from a state, something that we'd already been working on. But voila. Okay, that's enough. Next episode will probably be more specific engineering, back to specific engineering stuff. In particular, I think we're going to look at fundamental math concepts. So how equations of state and motion are represented using calculus, key concepts in linear algebra and differential equations. And then after that, we'll get to launch into sort of the real engineering meat and potatoes, starting with statics, which I'm pretty excited for. Hopefully you enjoyed this. We'll continue to alternate back and forth between engineering, fundamentals and software engineering stuff, but enough to keep you entertained. Have a great day. Take care.